Okay, this section today is going to help you with 4.6. So there's 4.6. We're dealing with imaginary numbers, and so the thing that's most important for us to remember is that when we see I, we mean square root of -1. If you see square root of -1, you should replace it with what? With I. Also important to remember is that I squared equals -1. Because if we square both sides, squares and square roots cancel and we get -1. Okay, but we're working over here. We're trying to solve for s. So the first thing we want to do is get rid of this 22. We'll do that by adding 22 to both sides. We will get s squared equals, now if I add 22 to -11, I think it's -90. To get rid of this square, I'm going to go ahead and take the square root of both sides. I know to carry my accessories, my plus minus. Over here I'm going to have s equals plus or minus the square root of -90. Now anytime I see this negative here, okay, anytime I see this negative number, sorry, anytime I see that negative, I am going to know that I need to have an I in my answer. And so down here I'm going to have s equals plus or minus. Okay, I've got three pieces. Okay, I know I've got an I, but I also know 9 is divisible by 9 and 10. 90 is divisible by 9 and 10. And then the square root of 9 is 3. Okay, so I've got an I, I've got a 3, and I've got a root 10. So s equals plus or minus 3i root 10. And that is my answer. So real quickly, get the squared variable alone. Take the square root. Make sure you have your plus and minus. Look inside. If there's a negative, that will come out as an I. Right here, we did that there. Then we factor the rest of it the way we did the day before. Okay. Number 18. Okay. All we're being asked to do is add these two together. So I know that real numbers are not the same thing as imaginaries. And so I cannot add real with imaginary. All I can do is add real numbers to real numbers. 10 plus -11 is -1. And real numbers always get to go first in these complex sets. Then -2 plus -7 is -9i. Very simple, not intended to be difficult. Add your reals, add your non-reals. If you're making a mistake, it's because you're making a mistake with your addition. Or you're forgetting that it's an addition and trying to multiply to FOIL these. Not our goal. 28 and 30 have a similar problem with the denominators. Okay, I'm not allowed to have this I down here or over here. We're going to approach them separately though, and we'll compare the two just slightly as we go through. All right, so over here first, let's look at our question over here. Just like we did the other day, when we have addition or subtraction in the denominator and we're trying to eliminate it, we need to use the conjugate. So 8 minus I on top and bottom. Okay. I'll know to distribute. So I'm actually going to write it down again. 7i times 8 minus I over 8 plus I, oops, 8 minus I. Let's clean that up real quick. Okay, so while I'm doing that, we know that we need to go ahead and multiply the top by distribution. Well, 7i times 8 is 56i, and 7i times -i is -7i squared. Down on bottom, I'm only going to do the first, which is 64, and the last, which is -i squared. Negative because I had a plus times a negative, that's negative. I squared because I times I is I squared. Now there's a couple of changes to make. Whenever you see an I squared, you're going to cancel it out and change the sign of the number that's with it. Because this is a -1. We talked about that earlier. I squared equals -1. So we replace it and multiply, that'll change the sign. Down here when you do it, be careful, you need to have a coefficient. So I'm going to put a 1 there as a placeholder so I have something to change the sign with. All right, now I know that real numbers should go first. So this 7 here is supposed to go first. So 7 plus 56i. Now I know the denominator will be 65, but I should have these split. So I'm going to write each of them with their own denominator. And then all I have left to do is to check, say, hey, is there anything I can reduce? There's not, so I am done. Number 30 is a little bit different because instead of having two things down here where we have to add them, the only thing we have is the I that we need to remove. I'm going to give you the advice that you multiply by negative I. It'll keep you from having sign problems at the end. So I'm going to multiply the top as well by negative I. This is just a simple distribution on top. Negative I times negative 2 would actually be positive 2i. Negative I times negative 5i, well, the negatives cancel, give me a positive 5i squared. Okay? Is that all right? Positive I squared. Okay. And then on bottom, when we multiply these, we will get a negative, because negative I times this 3, negative 3i squared. And then we're going to go in and make those changes that we talked about. We know every time we see an I, or I squared, it's negative 1. So we cancel it and change the sign. Okay, cancel it and change the sign. That leaves me with, if I put it in the correct order, real numbers first, plus 2i, and I want them to have their own fractions, so I'll put 3 on the bottom of each. And there is number 30. Much simpler. I don't have to do the foiling or the extra step of distribution. Not too bad. Okay, the last problem we're going to look at together is this. They want the absolute value of negative 1 minus 6i. Absolute value. Well, if I label this as my imaginaries, this is extra work over here, the graph. I'm just trying to make it make sense. And I put my real values here. I know these go up 1, 2, 3, 1, 2, 3, and so on. Over here, it would be I, 2i, 3i, and so on. So if I go ahead and try to plot this, negative 1's here, and negative 6 would be 1, 2, 3, 4, 5, 6. So this is my point. And the question that we're really being asked is, how far is it from here to here? That's the question that we're being asked when we say, what's the absolute value? How long is that line? Well, if I think about it in terms of right triangles, okay, I'd have this right triangle here with a length of 1 and a length of 6 to make its sides. I know from Pythagorean's theorem, a squared plus b squared equals c squared, that if I want the hypotenuse, okay, the long side by itself, take the square root, take the square root. C, that long side, would be the square root of a squared plus b squared. And it's positive because it's a distance. There's no need for a plus minus here. Now, where does that a and b come from? Well, a could be the distance here, which is 1, or negative 1. I'm going to square it, so it shouldn't matter. And b would be the distance along this side, which would be 6 units. So c equals 1 squared plus 6 squared. And c equals square root of 1 plus 36. C equals the square root of 37. Now 37 is a prime number, and that is as far as I can go. These square roots, these absolute values ideas are not hard. I would actually, for most of them, pick up right here. This is the equation I would plan to use. If you aren't sure what it is, or you forget and you're having a hard time remembering, just go back to the original Pythagorean's theorem and try to use the idea of a triangle. But that should be pretty helpful for you. Hope that helps. Good luck.